Hello everyone and welcome back to your second half of 3.3 and 3.4 lesson notes. This is all about higher power polynomials. A brief recap of what we have discussed so far. So if your directions say, here is a function, find the solutions. Your first option is it quadratic? Meaning, is the highest power a 2? If it is, then I can use the quadratic formula. Okay? If it is not quadratic, or maybe it is, regardless, your second option could be to factor it. Factoring can work when it is quadratic, or if the power is higher than that. So say it's got a power of 3 or a power of 5, on and on and on. If you don't know how to factor something, or if it is not factorable, then you have a third option. The third option is what section 3.3 and 3.4 is all about. Finding the solutions of higher power polynomials when you don't know or when you cannot use the quadratic formula or solve by factoring. Now, last class we started, and the only thing that we really discussed last class was the rational root theorem. And a reminder, the rational root theorem is the first step in our third option. So I want to find the solutions. I can't use quadratic formula. I can't factor. My third option is start with the rational root theorem and get a list of possible solutions. Possible is not actual. Possible is, these are my options. One of the things, one of you emailed me and was asking me to clarify that, and so the example I gave was this. So we're all at home, and we probably have gone to the grocery store potentially and stocked up on some food. And if you're like me, or maybe you're not, because I'm carrying around a 10-pound bowling ball, I have stocked up on a lot of sweet stuff. And so I get hungry all the time. And so right around 2 o'clock, which is what time it is that I'm recording this lesson at the moment, I lay out all of my options for snacks. And so right now I've got brownies that I could bake. I have chocolate chip cookies. I have some leftover cupcakes from a baby shower that got canceled. And I have some fresh fruit and some Kit Kats. Okay. Now, I am not going to eat all of those. Those are my options. Those are my possible snacks that I have laid out on the counter. Okay? And so that's my first step, is I'm laying out all of my options. Ooh, and don't forget peanut butter. Peanut butter and Nutella. Add that to my snack options as well. So I've got about 6 options for snacks. I'm not going to eat all of those. Those are just possibilities. My next step is, after I have figured out what my possibilities or what my options are, my next step is I need my actual snack. Otherwise, I'll just sit there and stare all day at my options. Okay? It's the same thing that we're doing here with solving polynomial functions. So last class, we looked at the possibilities. We looked at our options. Today, we are going to narrow it down and actually figure out what our actual snacks or our actual solutions are. And there is a very simple way to do that I also think a lot of you are going to enjoy, because it's not a very complicated process. I think out of all 3 of the options, quadratic formula, factoring, and then today's option, I think you're going to like today's the best, just because it's fairly simple. As long as you understand the rule behind it, understand like how to set it up, I think all of you are going to appreciate and choose this method more often than not. Okay? But what I've got in front of you is just a review of exactly how we started our last lesson. This is the exact slide from last class. Before we go any further, I want you to have your notes out from last class, because almost every single slide for our lesson today, I am pulling from last class. And so The reason why is because I don't want us to recreate the wheel and double up on how much time we're spending on things. So last class we did about 5 or 6 examples where we got the list of possible solutions. We're going to go back to that and look at that list of possible solutions and work from that to get the actual solutions. Okay, so pause this video right now if you need to, and I want you to go dig up and get out your notes from last class for the rational root theorem, because we're going to use those again for today's class. We're not going to take the time to do the rational root theorem over and over and over again when we already did it 5 or 6 times last class for some problems that we are going to finish today. So pause the video, go get those notes, and press play when you got them. So a reminder, here we go. We've got the function f of x equals 9x to the 7th plus 8x to the 6th plus 7x to the 5th plus 6x to the 4th. Now that is something that almost all of us would not be able to factor, and probably none of us would choose to factor. And we can't do quadratic formula because it is not quadratic. So if we're not going to factor it, then we automatically have to start with our third option. And part of that third option is the rational root theorem, which is take all the factors of the constant term. A reminder that our constant term is not written here, so we are going to say it is 0. And factors of 0 are just plus or minus 0, divided by the factors of the leading coefficient, which is 9. And the factors of positive 9 are plus or minus 1, plus or minus 9, and then plus or minus 3. And then we rewrote all of those as individual factors, and what we found very quickly is that it simplified down to just 0, all of them did. So what this tells us is that out of all of the possibilities, there is only one possible rational or real solution, which could be 0. That means that all the other ones are imaginary. So again, possible. I need you to always keep that in mind. Possible does not mean actual. Because we have 0 sitting right here, that does not mean automatically that it is an actual solution. It is a possibility. And the only way we know that it is an actual solution is if we test it. We have to have a second part or a way to test to see, is this an actual solution or is it just a list of my possibilities that I'm going to throw out? Okay? And so the way that we test that is something called synthetic division. Okay, I want you to write that down in your notes, synthetic division. So here is our learning target slide. I hope by now you've picked up on the fact that our learning target slides are always this turquoise aqua blue color. That way you can find them. You know exactly what we'll be learning about in today's class. Okay? But here is kind of what I just said. Once we have made our list of possible solutions, now we have to figure out which ones actually work, aka which ones are the actual solutions. And the way that we're going to do that is synthetic division. Now before we go any further, let's do what we always do, even if we're not face to face. Let's pull out those key words in that learning target. So test. So we're going to have to take some type of action and actually test those possible solutions. Possible meaning they could be actual solutions, they could not be. We have to figure that out. Actual meaning it is an actual solution. If we graphed it, it would show up on the graph. Okay? But then the big key word, the one that we may not be familiar with, is synthetic division. Now I think we all understand division, although the irony of that is that even though this process is called synthetic division, nothing about it requires you to divide. It requires you to multiply and add, but we digress. It's called synthetic division. But let's kind of dig into synthetic, okay? So if something is synthetic, what does that mean? Okay? Like if I have a synthetic material, then that means it is not made out of real materials, right? It wasn't grown. It didn't take the time to grow and mature, or to be harvested in the appropriate way. It's not genuine. It's a shortcut, if you will. It's a way to mass produce something at a faster rate, even though its materials are not raw or not genuine or real. Okay? So synthetic division is not going to be the genuine type of division that we are used to. Okay? And, you know, honestly, I say that, but I should really kind of backtrack on that. How many of you remember doing this in school? Because when I was in school, I had to do that. But with your generation, a lot of you were just handed calculators and told to type it in. But our typical way of division is either setting it up like that on the right or doing something like this by hand, where 2 goes into 52, 2 goes into 5, 2 times, which is 4, minus that is 1, bring down the 2, 2 goes into 12 6 times, and there's our long division method. Okay, so 52 divided by 2 is 26. That is real, genuine division. Okay, synthetic division is not the same thing. Like I said earlier, synthetic division is so simple that you don't even actually divide anything. Okay, you're actually going to be adding and subtracting, adding or subtracting and multiplying some things. So we won't even set it up using this type of division bar. It'll look backwards, actually. It'll look like this. Okay, so the next slide I already have written out. I already have it typed out for you as a specific example. Okay, so I'm not sure how you want to handle this. You may just want to pause the video before I start talking and allow yourself a few moments to just get that copy down first, and then you can press play and listen to me talk through it. Or you can listen to me talk through it first and then you can write it down. I would encourage you to do one of those. I would not try to copy it down while I'm talking, otherwise you're going to miss some key information. Okay? So go ahead if you want. This is the part I'm talking about right here. That's the example that we'll be taking a look at. If you want to pause the video now and just get that written down, you can. Or if you want to listen to me talk through it first and then pause at the end, you can do that as well. Okay. Synthetic division, again, is a shorter method of dividing. And since we are dealing with functions and equations, higher power polynomials, it is a way of dividing a polynomial by a binomial. Okay. Now, don't get freaked out. Remember at the end of last lesson or last class, we had some things like, I said, okay, x equals 2, write a function. And we said, all right, we'll just subtract 2 to get that factor group. Well, x minus 2 is a binomial, okay? So I don't want you to get freaked out by that wording. I do want you to write it down, okay? But I don't want you to get freaked out by that because that's what we've been dealing with the whole time. Binomial, bicycle, that two terms, x and negative 2, okay? All right? It must be in that format, x minus a number or x plus a number. This method will use coefficients of variable terms. And this next part is really really important. I would definitely say write that down, and we will look at why that's important in some of those examples on the next slide. And then lastly, make sure that your function or your polynomial is written in standard form or descending exponent order. Okay. Pause the video if you need to. Okay. So here's our example. We have 2x cubed plus 4x squared plus 3x minus 2. And I want to divide that by x minus 6. Okay. Now, let's go through the little checklist that I gave you up top here to make sure that you can do synthetic division. So first of all, we are dividing a polynomial, this right here, we're dividing a polynomial by a binomial Binomial is two terms. Okay. The binomial is in the proper form, x minus a number. Okay. The method uses the coefficients of variable terms. We'll get to that in a second. Remember to account for missing terms. So let's talk through that, and then we'll actually get into the division piece. I want you to look at your polynomial function. Okay, 2x cubed plus 4x squared plus 3x minus 2. Is that function written in standard form or written in descending exponent order? Meaning the largest exponent is first, followed by the next exponent and the next one and the next one all the way down to a constant. Okay? The answer that you're looking for is yes, it is. It is written in descending order. Now the other thing, and that this is the one that I was telling you to star. Are there any missing terms? Meaning our largest term is 2x cubed. The next largest term should be something x squared. Do we have that? Yes. The next largest term down would be something x to the 1 power, or just something x. Do we have that? Yes, we do. Okay. And then lastly, the next thing, the next largest term would be a constant, no variable at all, and we have that as well. Okay, so that is what that statement means up there, to account for missing terms. Okay, we will 100% look at an example where we have to fill some things in today, so don't stress out about that starred statement. We will look at that, and I will clarify that in a later example. So just hang with me for right now. This is brand new for a lot of you. Okay. So our directions say I want to divide 2x cubed plus 4x squared plus 3x minus 2. I want to divide that polynomial by x minus 6. Now the way that we use synthetic division, assuming that all of these things up here are good to go, meaning it's written in descending order, there's no missing pieces, and we are dividing by a binomial, we can move on. So here is how we would use synthetic division. Remember how I told you this, even the division bar is going to be upside down? In your notes, if you haven't already, I want you to draw a division bar that really is upside down. It looks like a sideways L. Okay. Then, okay, we are going to take the coefficients of every term in our polynomial. So our largest term, what is its coefficient? It is 2. Okay. Our next largest term is, what is its coefficient? It is a positive 4. Okay. Our next largest term, its coefficient is a positive 3. Okay. And then our next largest term is negative 2. And so already we are setting this problem up to divide, and once we get it set up, it will go through, it'll go very quickly. Okay. Grab your calculators if you don't have them, because you'll definitely want them. Okay. Now we are dividing by x minus 6. Okay. Well, x minus 6 is a binomial. It is a factor piece, right? So what would x equal? X would equal 6. Okay. If this is a solution, then that means, if I can divide by 6 here, then that means that x would be a solution for this function. Hopefully you can kind of see where we're going here. Okay. Regardless, x minus 6 would mean that we are dividing by 6. Okay. Now, pause this video if you need to catch up, or if you need to jot down some questions. Otherwise, here we go. So we've got the setup of synthetic division. Now we just need to actually do the quote dividing. Okay. Here's how we're going to do this quote dividing. It's not dividing at all, but it's easy, so we won't complain. Okay. Our very first term is a 2. I want to bring that 2 down. And now I am going to say whatever I'm dividing by, 6 times this first number. What is 6 times 2? 12. Bring that 12 over to the next column and write it down. And I want you to add those two numbers together. Add them down. 12 plus 4 is 16. All right. Now you're going to take the same number that you're dividing by. You're going to say 6 times 16, which is 96. Write 96 in that next column over. Add those numbers down. 96 plus 3 is 99. And then lastly, what is 6 times 99? That would be 594. And add down. So what is negative 2 plus 594? 592. Now, just like we would do with any other division problem, especially way back in elementary school, when you would divide numbers, so say I asked you to do 49 divided by 5. Is that going to come out as a nice, pretty whole number answer? 49 divided by 5. No, it's 5 is not a factor of 49. It's going to go into that 9 times, but there's going to be a remainder. Anybody remember that from elementary school? When you divide certain numbers, if they are not perfectly matched up, meaning they're not factors of each other, or they don't divide evenly into each other, or as a whole number into each other, then you will end up with something that is called a remainder. Well, you can have remainders with functions as well. Okay? Case in point, this back number back here, 592, that is always going to be your remainder. Okay? No matter what is sitting there, whether it's 592, whether it's negative 1,000, it might be 0. That last number will always represent your remainder. Okay? Now, again, remember what I just said. If 49 divided by 5 has a remainder, so is 5, I'll write that to the side just to help us visually, is 5 a factor of 49? If it won't multiply into 49 perfectly, then is it a factor? No, it is not. So immediately, if there is a remainder here on this division problem, is 6 a factor of this function? The answer would be no. And if it's not a factor, then it can't be a solution. Okay? That is where we are going for today's class. We're going to take all of those possibilities and we are going to divide them into functions. If they have a remainder, then they are not the actual answer. If there is no remainder, then they are an actual solution. Okay? And we'll talk through that. We'll look at some very specific examples, like I said earlier. We'll do that. Let's finish up this problem. Okay? Now, you have done all the algebra calculation stuff. The last thing that you have to do is to actually write your solution. So the direction said divide this, provide your answer. So your answer is going to be something like this. Now, you're going to notice that I'm going to start at the back, and you'll see why here in just a second. Okay, 592 is my remainder. Okay. And the way that we formally write a remainder is to say 592 divided by whatever we're dividing by. Okay? So we have a remainder of 592. We are dividing by x minus 6. Okay, and now we are going to work our way back to the left. Okay, so what is the smallest type of term in standard form? Okay, up here, what's the smallest term or the smallest type of term in standard form? It is a constant. Okay, just like up here in the original polynomial, it is a -2. That is just a constant. When we are writing our answer, that next number to the left is a constant. So we're just going to write it as 99. Okay. The next number to the left will be the next largest term. Okay. So the next largest term would be something x. Okay. And then the next largest term would be x squared. So we would have 2x squared. If there was something else past that, we would go up to something x cubed, something x to the fourth, on and on and on until we ran out of stuff. Okay? That is what is being said right here in this statement here. When you divide, when you do synthetic division, whatever your largest power is originally, subtract it by 1, and that will be your largest power in your answer. Okay, so you can either remember it like this, or you can work backwards like I just did, and you don't have to think about that rule. That is completely up to you. Okay, my suggestion would be to pause this video, write down some notes if you need to, go back and copy this example down now that we have talked through it, and then we're going to move on. Okay, so here's what we're going to do. I have pulled the 4 examples that we used from last class, and I have already included the possible rational roots on this slide. So this is why I was asking you to get your notes out from last class, so that we don't have to sit here and write out all the factors of the constant divided by factors of the coefficient and simplify it down for each problem, since you've already done that. Okay, we'll do that to wrap up the end of class on our next slide. But for now, I really want us to just have a few minutes of just practicing synthetic division, since it's the really new thing. So here we go. Number 1, which is the one I'm starting out with, f of x equals 3x squared plus 2x minus 1. And last class we found the rational roots, the possible rational roots, to be plus 1 or minus 1, and plus 1/3 minus 1/3. And so now we need to find the actual rational roots. Well, the way that we're going to do that is we are going to do synthetic division using positive 1. We are going to divide by -1. We are going to divide by 1/3. And we're going to divide by -1/3. And we're going to do that for every single problem until we get our solutions. Now, one thing that I want to remind you, for this function, 3x squared plus 2x minus 1, this is a quadratic function. So you could do the quadratic formula on this and get your answer. Okay? I'm trying to start you out with an easy one so we can see how to do this process, and then we'll build up into some bigger ones. Okay? The second thing that I want to remind you of is this. What is the largest exponent on this function? It is a 2. So how many total solutions will I have? I will have 2 total solutions, meaning I will have 2 actual solutions, and that's it for this function. Okay? So what does that mean for us? That means if we use synthetic division for positive 1 and it works, then that's one of our total solutions. If we use synthetic division for -1 and it works as well, then we have 2 solutions. We have 2 actual solutions. Do I have to test the other possibilities if I already have my 2 that work? The answer would be no. Okay, so without further ado, let's get started. we want to divide 3x squared plus 2x minus 1, and we want to divide it by each of these possible rational roots. How will we know if the possibilities are the actual solutions? There will be no remainder. Okay, I'll say that again. We will know that a possible solution becomes actual if it divides into our function with no remainder at the end. If there is a remainder, it's not a solution. If there is no remainder, then it is a solution. Okay? You might want to pause the video and rewind that to hear me say it so you can write it down. Okay? Here we go. First thing I want to do is I want to check to see that my function is written in descending order with no spaces, meaning if my largest power is a 2, then the very next term should be a power of 1, and the very next term should be a constant. And I have that, so I'm good to go. Okay, so what are the leading coefficients of my function? 3, positive 2, and negative 1. And I am dividing by whatever my possible solution is. So what we saw earlier was dividing by a binomial, like x minus 6, and we solved that to be x equals 6. Well, we already have those solved here. So it's positive 1 is what we would be dividing by. However, I want you to remember that that's x equals 1, which means as a factor it'd be x minus 1. Okay? We might need that if there is a remainder. Okay? If there's a remainder, remember we have to use that factor piece to write our answer. Okay? So here we go. Let's get started. The more we do of these, the easier it will be, and you will be able to blaze through these very quickly because it's not a very difficult process, I promise. Okay. The first step in actually doing synthetic division is to bring down the first term, which is a 3. What is positive 1 times 3? That is 3. Bring it to the next column. Add down, which is 5. What is 1 times 5? 5. Take it to the next column. Add down, and you will have 4. And so remember, this very last box is your remainder. Do I have a remainder? Yes or no? Okay. Yes, I have a remainder. So is this a solution? No. It's not an actual solution. Okay. And then from there, remember, you can work backwards. That very back number is your remainder. The next number is your constant, okay? And then the next number will be your x term. Okay? Anything beyond that would be x squared, x cubed, da 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 da. Okay? So for this question, it says determine the actual rational roots. Okay? Is positive 1 an actual rational root? Okay? The answer is no. Positive 1 is not a solution. So I'm going to scratch through it because it's not an actual solution. Okay? If positive 1 is not an actual solution, then that means we need to go back to our list of possibilities and test our second option, or as a second option. Okay? So the second, or the next thing we need to do is we need to test another one of our possible solutions. So look at your list. We can test negative 1. Now I want to remind you that this is x equals negative 1, which means as a factor group or as a binomial, that would be x plus 1. Okay? And we'll keep everything else the same. So the 3, the 2, and the negative 1 are going to stay just like that. However, you don't need to erase anything. So when you are testing a second solution, you need to leave a little bit of space and in your notes, draw a new division bar. Okay? And rewrite 3, 2, negative 1. If you do not leave that original work there, then you're not getting credit for showing me that work, and you must show me that work. Okay? So you should have a completed synthetic division problem for positive 1, and then we should be starting a second one for negative 1. Okay? Now, drop the 3. What is negative 1 times 3? Carry that to the next column. Add down. What is negative 1 times 5? Carry that over and add down. If that's weird to you, you can type it into your calculator, but it's negative 1 plus negative 5, which is negative 6. That very last number is your remainder. Okay? So, do I ever have a remainder? Yes, I do. Okay? If I have a remainder, do I have an actual solution? Okay? No. No actual solution. Okay? So that means negative 1 is also scratched out. It's not a possibility. Okay? Now, if your direction said write your answer, like write your division function answer as a function in itself, or if it says something like divide, provide your answer in standard form, then I want to remind you, just like what we did on the earlier slide, we would have our remainder, which is over the factor or the binomial. For this one, it'd be x plus 1, plus that constant, plus the next term, which would be something x. And that would be our solution to dividing. If the directions said divide, provide your answer as a function in standard form. Okay? The directions here just say find the actual solutions. So we aren't required to give that. We're just, our sole purpose is looking for those solutions. Okay? So positive 1's not going to work, negative 1's not going to work. Let's test positive 1/3. Okay? So in your notes, we are going to test positive 1/3. So I'm going to create yet again a third division problem or piece. I'm going to add or write down 3, 2, negative 1, those leading coefficients again. I will remind you that positive 1/3 is the same thing as x equals positive 1/3, and that as a binomial would be x minus 1/3. And then from there, do your synthetic division. So bring down the 3. 1/3 times 3, this is a good time for a calculator. 1/3 times 3 is 1. Bring that to the next column. Add down. 2 plus 1 is 3. 1/3 times 3 is again 1. Carry that over. Add down, and we get 0. Now, do we have a remainder? This time we do not. No remainder. So if there is no remainder, is 1/3 an actual solution? And the answer is yes, it is an actual solution. Okay? So positive 1/3 is one of our solutions. We want to keep it. Okay? We are not done because remember, there are 2 total solutions here. I've only got one of them. I need to test my last option up there in my list to see if negative 1/3 is that last solution. Okay, so go ahead, pause the video, see if you can do this one on your own. So when we work that one out, we end up with a remainder. So if there is a remainder, it is not an actual solution. Okay? If we were to write that answer out completely, when I divide that function by negative 1/3, my answer is I have a remainder of 1 1/3 over my binomial plus the constant plus the next x term. Okay, but there are no actual, that is not a solution. Okay, if you were asked to write your division answer as a function, this would be it. Your directions for these specific problems say find the actual rational roots. Well, what is the only root from our list? What is the only root from our list that actually worked? And what is the only root from up here that actually worked? Positive 1/3. And so our answer for these directions would be determine the actual rational roots. The only actual rational root that 3x squared plus 2x plus 1 has is positive 1/3. Now what does that tell you about the other solution? Okay. It's got one imaginary solution. Okay. Pause this video, jot down some more notes, rewind it if you need to, write down some questions if you need to. We are going to move on to one of these other problems. All right, everybody. Hopefully you paused it and you had some time to jot those down. Here would be my suggestion, just based on the time that we've got, because I want to respect your time. We're sitting at 42 minutes for this lesson already, and I just want to be respectful of your time and manage that well, and not take way longer than we would actually in class like normal. If you look at your notes from last class for the second, third, and fourth functions here, you will notice that there are a ton of possible rational roots. Like for number 2, there are 2, 4, 6, 8, 10, 12. There are 14 different options of solutions. Okay. For number 3, for that third one, there are 2, 4, 6, 8, 10, 12, 14. There are 16 options for you to test. And then the fourth one, there's 2, 4, 6, 8, 10, 12, 14, 16. There's 18 different possible solutions for you to test. I want to be very clear and upfront in saying that I would never ask you to test 18 or 16 or 14 different solutions on your test. Okay? I will say that again. I would never give you problems like 2, 3, and 4 and say, find the actual roots, where you have to potentially divide 18 times for one problem. That's not feasible. That is not logical when you've got a whole test of other questions. Okay? So hear me when I say that. Now, what could happen? Okay? The example that we just did is a great example. You had 4 that you had to test, and we ended up testing all of them. Okay? The max that I would give you is a list of 8 possible solutions that you have to test, and that's it. Like, I would not go over 8, and you would most likely find a good number of those at the very beginning in like positive 1 or negative 1 or positive 2, negative 2. Okay? Not always a guarantee, but what I am telling you is that on your test there will be a max of 8 possible rational roots for you to test using synthetic division. Oh, can't spell. Really can't spell. Ooh. Now, That does not mean I'm going to give you those possibilities and then you get to go test them. You will have to go find those possibilities first, just like we found them first last class, and then today's class we are testing them. You're definitely going to have to do that. Okay. So just like if I gave you number 1 from scratch on your test, determine the actual rational roots, you would have to go do the rational root theorem first to get your options, and then do synthetic division to figure out which ones actually work. Okay. And you'll see some examples of that on this next slide. Okay, here's some great examples for us to take a look at to really wrap up today's lesson, combine everything from last section and today's section, and to wrap up chapter 3, because remember, this is our last section before our chapter 3 review and test. Okay. So let's take a look at our directions that say state the possible rational roots. So first step is we are going to get a list of the possible solutions. Okay. Then step 2, use synthetic division to find all the actual rational roots. Okay, so we're going to do this in chunks. So for number 1, I want you to pause the video and I want you to write out your list of possible rational roots. That is something that we did last class, and what I read from everyone's emails that responded back, you all understood it very well, so there should be no reason why you're not able to do it today. So pause the video for that first function, x cubed plus x squared minus 5x plus 3. I want you to write out your list of possible rational roots. Okay. All right, check your answers. You should have 4 possible solutions or 4 possible rational roots for number 1, plus or minus 1, meaning positive 1 is a possibility, negative 1 is a possibility, positive 3, and negative 3. So 4 possibilities there. Okay. Now I want you to pause the video and start using synthetic division to evaluate and find all of your actual rational roots. Okay, ladies and gentlemen, I want you to see what just happened. I worked through the entire problem, but what you couldn't see was me checking my answers in the calculator. And what I did was I just graphed it and I traced it to make sure that all of my possibilities were not solutions. Meaning, if I graphed it and then pressed the trace button and typed in +1 and hit enter, then its y value should be a 0 if it is an actual solution. Okay. When I trace +3, it won't have a y value of 0 because it is not a solution. Okay. So when I tested those, I realized that I had made a mistake on -3, and it was a very easy mistake. And I want to point this out to you because this is something that a lot of people do. Okay. My careless mistake was I said -3 times -2 was 5, and that is not the case. -3 times -2 is +6. When I add those down, that gives me a 1. -3 times 1 is -3, and when I add those down, I get no remainder, which means this is an actual solution. Okay? So you always want to be very, very careful when you're doing this, because you'll get in a hurry just like I did, and you'll make a mistake. And then it'll throw your whole problem off. So slow down and then check your answers in your graphing calculator to make sure that what you've got is actually correct. Okay. For number 1, you'll see that I found 2 actual solutions. How many total should I have? I should have a total of 3 solutions. 2 of them are rational or real. So what does that mean about the last one? It is imaginary. So we wouldn't ever be able to actually see it or graph it on our calculators or on paper. Okay? But we know that 2 of them are real, and the third one or the last one is imaginary. Okay? Go ahead, pause this video, and I want you to try the second one. Okay? I'm going to do it the same way. I'm going to let you have some time to pause the video, and then I'll put the possibilities up, and then I'm going to ask you to pause again and check your answers to see what you get for the actual rational solution. So pause this video, try the second one. Check your answers. For the second function here, we also have 4 possible solutions. That is right within the range that I told you could be on your test. Testing 4 possible solutions to see if they're the actual answers is very reasonable. Okay, so this question is also something like this is fair game. Okay, go ahead and pause the video and start testing +1, -1, +2, and -2. Start testing them using synthetic division to see which ones are your actual solutions, if any of them. Pause your video now. Okay. Take a look. This is what your paper should look like. There should be 4 synthetic division processes on your notes. So if I asked you wording like this on your test, I would expect to see your work for the possible rational roots and the 4 synthetic division operations happening for the one problem. Okay. Now I went back through and I graphed this function on my calculator or on Desmos, and I traced it. So I traced what is the x value, or when the x value is +1, what's the y value? And it was not 0. Okay, so it's not a solution. -1 was not a solution. +2 or -2, neither one of them were solutions either. So this is a weird situation because we've got 4 possibilities, but none of them worked. Okay, go back to your original problem up here. How many total solutions can we have? We can have 3 total. Well, are any of them rational or real? Okay. None of them are, because we tested all of the options. So no or 0 rational solutions. So what does that tell you about the other remaining ones? Okay. That means there are 3 imaginary solutions. And that's what I'm looking for this problem. Your answer, if this was a problem on your test, your answer would be there are no rational roots. There are no actual rational roots. All three are imaginary. And you would have provided evidence and showing the work right there. Okay. Pause your video one more time and let's do the third one and then we will wrap up. Okay. Alright, so when we write out all of our possible rational roots, we simplify them. We don't write down any repeats. So there were a couple of repeats in here. So you don't have to double up and write them again. Once you've got them once, you don't have to write them twice. Okay. And so everything in blue at the bottom are our possible rational roots. Now there's a lot sitting right there. Remember I told you on your test, I would not give you a problem that required you to test more than 8. Okay. However, these are our notes and we can use all the practice we can get. And so I'm going to suggest that we work through this problem. Okay. Remember, keep in mind that we only need to find 3 that work. And so I bet we will probably not end up testing all 3 of these. I could be wrong because I haven't done it yet, but we may not end up testing, testing all 18 of these possibilities. We just need to find 3 that work and then we'll be done. Okay? So that means you need to pause this video and you might potentially need to do synthetic division 18 times to see if these 18 possibilities, which ones are your actual solutions. Again, I will not ever ask you on a test to test something 18 times, but we are practicing this for our notes and for our retention, and so I think that we should practice this one. Okay? So pause this video and begin testing each of these roots to see if they work. Now that should have taken you a good chunk of time because unfortunately out of all of those 18 possibilities only 1 worked. Okay. And I did not have enough space on my little tiny screen to show all 18 of those. Okay. So I showed you the one that did work, which was the solution of -3. Okay. And I know that because there is no remainder. Okay. And so just to go back to what we started at the beginning of the lesson, synthetic division, if the direction said divide, provide your answer in function form, your answer would be, there is no remainder, so it would be 0 over x plus 3, because remember this is the same thing as a binomial. And then your constant. Okay. Then your x term is next, and then if there's something after that, the x squared term. Okay. That's if your direction said divide. Provide your answer in a function form. Okay. The directions here say, tell me the possibilities, which is down there in blue, and then find the actual. The only actual solution is x equals 3. The only actual solution is x equals -3. Now, there's a total of 3 solutions. There's 1 rational. So what do we know about the other 2? The other 2 solutions are imaginary. Okay, the last thing that I want to address with you before we finish up for today is something that I promised you at the beginning of the lesson. Let me back up right here. Remember at the very beginning, this statement right here that says, remember to account for missing terms by using 0 as a placeholder. Okay. So I want to take you back to this slide. Okay. I want to take you back to this slide. I'm going to clear everything out, and I want us to look at number 2. Now, we did not actually find the actual rational roots for number 2 because there were so many to test. Okay, we've done one Mac Daddy problem like that. We're not going to do another one. Okay, But I do want to show you how to set this up, because on your test, I may say something like divide x to the 6 minus 64 by x minus 4. Okay, I may ask you to do something like that. Okay, and so the first thing that we would do is set up our division bar. Okay. X minus 4 is the same thing as x equals 4. Remember, we add that, set it equal, and add to both sides. And so we would be dividing by 4. Okay. And then we have to take our coefficients from the original polynomial. So some coefficients that I can see are negative 64 and a positive 1. Okay. So I can write those in, 1 and a negative 64. Here's the issue though, is x to the 6 minus 64 written in descending order without gaps? And I am hoping that you are saying no, it is not. Okay. We go from x to the 6th to a constant. Well, what about x to the 5th? What about x to the 4th? X cubed, x squared, x. All of those are missing. We can't have any gaps when we do synthetic division. That is the one crucial piece that you have to remember. We cannot have missing gaps. Okay, so that starred statement at the beginning of our notes, here is how that is implemented. If we're missing, like if we start out with x to the 6th, like in this problem, but then we're missing an x to the 5th term, then we have to fill that in by saying plus 0x to the 5th. Okay. And then keep going. Are we missing a 4th term? Because that's the next one down. Yes, we are. So plus 0x to the 4th. Are we missing a cubed term? Because that's the next term descending down. Yes, we are. So we have to fill in 0x cubed. We're missing our x squared term. We're missing our x to the 1 power term. All of those have to be filled in, and then we keep the negative 64. So setting this problem up for synthetic division is not going to be coefficients of 1 and negative 64. It's going to be 1, 0, 0, 0, 0, 0, negative 64. And then bring down your first term, multiply, add down, multiply, add down, multiply, add down, okay, you notice I kind of wrote this pretty tight. Hopefully you aren't. Add down, times 4, add down, multiply again by 4, and add down. So is 4 an actual root or an actual solution for this function? Absolutely not, because it has a remainder of 4,032. And so the way that we would write our final answer, if the question said divide x to the 6 minus 64 by x minus 4, remember when we write our remainder, we have to place it as a fraction over whatever we're dividing by. We have to place it over that binomial. So we would have to say the remainder of 4,032 divided by x minus 4 plus our constant plus our x term plus our x squared term plus our x cubed term plus our x to the fourth term, and we still got one more, plus our x to the fifth term. That would be our final complete answer for that one problem that looks like it would be very simple. I would put a star by that. You're going to see something like that on your test, almost identical to it. Okay. All right. I want to look at that third one before we finish up, just setting it up. We won't actually divide it, but I do want to just set it up, make sure that we're all clear on that. Okay. Let's say I want you to divide 5x to the fourth plus 32x squared minus 21. Say I want you to divide that by x plus 2. Okay, we'll go ahead and draw your division bar. I'm going to draw mine bigger this time. Okay, I'm going to be dividing by x plus 2, but remember, x plus 2 has to be solved so that I get an actual number to divide by. So I'm going to be dividing by -2. But if there is a remainder, I've got to remember to write this as part of that remainder at the end. Okay. Now I need to take a look at my actual function. Is this function written in descending order or standard form without gaps? Meaning the highest power is 4. Does it go something x to the fourth plus something x cubed plus something x squared plus something x plus your constant? Okay. This one has gaps as well. So we need to fill in those gaps before we try to divide. If you do not fill in those gaps, your problem will be wrong from the very beginning, and there's no way to save it other than starting over. Okay. So 5x to the fourth, now we need to fill in a gap, plus 0x cubed. All right, our next term we have a squared term, but the next thing in descending order is x to the 1. We don't have that, so we got to fill that in. We do have a constant of -21. Okay. So now that we filled in the gaps, we can pull the coefficients into our division problem. So we can pull the 5. We'll write, or pull a 0. We'll pull a positive 32. We'll pull a 0 and a -21. And then complete our synthetic division. And go from there. If you have any questions, feel free to email me, just like we did last time. That was a great system. I love seeing the feedback and hearing your questions. I believe that that's probably the most feedback I've gotten from all of you all semester. And so, just like last time, that is going to be a norm. After every video lesson, I want a separate email from you that you create that tells me one thing that you understood about the lesson and or one thing that you weren't quite sure of, and you must cite a specific example from the notes in your email. Whether you understood it or whether you have questions, you've got to give me that example. Otherwise, you're not going to get full credit for your email check-in response. Okay. That is all I have for you guys today. Sorry that we went a little over, but we're still within the time constraint of a normal class period. Let me know if you have any questions in that email that you send me, and stay tuned for some details about next class for our test review. Have a good one. Bye-bye.